Thank you, Jonathan. Thank you, Nimra, Ami, Juliana, and all of you for your presence here. And I'm really happy to share with you some ideas about what we understand as a greener or more sustainable curriculum, or I prefer always the plural way to see things. And thank you for the kind introduction, Jonathan. I think it's important to say that I worked for many years in Brazil, and I'm a Brazilian. I'm very proud of that. And currently, I am a full professor at the Faculty of Sustainability at Leuphana. I will talk a little bit about why I am working here, and you understand the reasons. But to start, and please, you can just let me know when I am like time or not, but to start, I'd like to consider this agenda. I think it's important to define what we understand as green and sustainable chemistry, and of course, education about that. And I'm working a lot also with PhD students and postdocs, considering case studies. And I'm going to explain what we have as perspectives as a collective here. So I think it's important to see that chemistry, of course, it's important, and more than chemistry. I think the future will be just chemistry again, but we need to highlight now that we need green and sustainable chemistry too. And we can see that, just a moment, chemistry is the science of transformation, but also, I don't know if it's a little bit noisy. There is noise, yeah. It's about transforming people, and education is about that. And I'd like to ask you what kind of production, mass distribution, and also disposal of increasingly complicated and persistent chemicals that we have today in some ecological and socio-environmental kind of damage that we have today. So what we are doing actually as society, and who will be affected more? We know that some people, unfortunately, could be more affected. So how should chemistry, and of course green and sustainable chemistry, move forward, considering what is enough for a fairer and also a healthier life for all? So should we do chemistry as usual? That means to produce, use, dispose, and negotiate molecules that address just superficially today's challenges, while we are pretending to ensure we understand and control the effects of complex and also chemicals that are everywhere in our health and towards a toxic-free environment. This is European, let's say, approach to construct a toxic-free environment. I would prefer a healthier environment. And let's think about this graphic here. So according to this study, the predicted changes in population and the production of chemical goods, it's quite, I think, interesting, because by 2050, we will have more chemicals, according to the CAS, than people in the world. Let's think about these numbers. I think it's quite interesting. And we know that we are actually, you know about the war here in Europe now, and in this kind of a very complicated world that we are living, questions such as why and for what purpose and for whom should be answered. And also we need to think who are the, or could be the stakeholders or institutions and cultures that need to be taken into account for not only chemistry. Why I am saying that? Because green chemistry, it's like a very important part of sustainable chemistry. Sustainable chemistry, it's wider in the sense that we also consider human sciences to meet this fairer, let's say, and healthier world. And we are also concerned at individual substances, but also related products and materials. And we are attempting to understand and incorporate advances from other fields, like I mentioned, from social sciences, from medicine. And then we can understand alternatives that also are not including chemical processes. That is, it seems strange, but it's not actually. Yeah, and when we are thinking about education, you can see this is described in the literature that there is an effort, and maybe we need to think more about that, how to include green chemistry and to establish this sustainable chemistry thinking in academia, but not only at our universities or schools also, but in other sectors. And as you know, many chemistry curricula are already overcrowded. So we have a very long list of topics that should be considered during this academic year, for instance. And we have also both individual and institutional resistance to include by now just green chemistry content. Why? Because it takes time and also a lot of energy to transform the curricula. For instance, we can think about experiments. Sorry, Moses, I think there is, yeah, thank you. And then, as you can imagine, we need a more dialogical process also related to chemistry education. To me, curriculum is understood as a way, it's a process where students also can build their understanding of concepts and processes from experiences rather than a prescriptive, let's say, like a list, a checklist to be covered. So it's something richer compared to a normal kind of understanding of curriculum. And what we can see, the most engaging chemistry courses begin with a contextual perspective, like the context coming from the contemplation of sustainability, integrating, for instance, circularity, bioeconomics, and systems thinking, and lead on the development of chemical concepts rather than placing these concepts at the very first moment. So we are starting from the broader view, and then we can go, let's say, to the more specific topics. This is, we are seeing, we have very beautiful results. And if the same classes have been taught in a similar way for decades, we can think again about the experiments. If we embrace some like green chemistry principles without paying attention to these multidimensional impacts, so maybe there is a little possibility of introducing the necessary changes that we need in these professional ethical standards, or let's say, I would say today that we need to talk about post-sustainability, okay? But this is a matter to discussion later. But this moralistic view, since the very beginning, it's a kind of very fruitful approach. And if we are also taking into account the UN SDGs, we can promote the scientific literacy that is so necessary and foster co-responsibility and the creation of societal partnerships, even with the students. And then, for instance, a concept like chemical leasing could be also discussed in a model that we are doing here. Learning and applying chemical concepts, putting together ethical values, can lead to an improved critical observation. Let's say we can work with emancipation. That means reflections and actions to create a more sustainable reality or realities. And the way that we are doing that is studying, for instance, some real problems. So this is an approach, also it's a method known as case studies. I am bringing just one because we don't have time, but this study was started in Brazil, but we are also doing this kind of application here. And we have a report. If you are interested, you can just see this this code here. It's the title is Plasticized Childhood, and we try to understand the nature of the material used to produce toys, but also the let's say we have the material dimension, but also the non-material dimension that is related to education. And I would like to highlight that we have more than 90% of our toys today in all over the globe, that they are made of plastic materials. And despite we know that in some labels we can see that they can be recycled, but actually they are not. And according to this study, we have potentially very toxic chemicals, not only to children, but of course for people dealing with these toys. So, and we also studied the correlation of these products, toys, with consumerism. But there are many ways to show how a product could be showed to children. One of them, it's like asking to some influencers, kids, like YouTubers, to do the unboxing. And we have this. So we have two products. One, it's the LOL Surprise. If you need to know more, you can just Google what is LOL Surprise. It's a doll. And you can see the problem is not only the doll, but the packaging. And we also studied the Happy Meal. Actually, the toy that is like inside this pack can have a role or a function for only maybe 5 minutes. It depends the children, I think. But we noticed that we have many problems related to these materials, the products, I mean, and we have also some, let's say, good proposals related to that, how to design healthier, greener, or more sustainable toys. Actually, first, we have to provide a very or more interesting purpose that could promote and stimulate creativity. And this toy, of course, shouldn't offer any kind of risk to health. It should have a long life cycle and also creating values regarding durability and recyclability. That means we need to consider the mixture of materials or plastics that we have there. For instance, with glitter, it's really difficult to separate and also to recycle these materials and many other aspects. Regarding this, I would like to invite you, if you are interested, we are launching a special issue about this topic in a journal that I'm also a co-editor. And we have many courses also dealing with this kind of introduction to green and sustainable chemistry. One of them, it's available, it's free at my former university. You can access this, it's in English also. Another one in Portuguese, unfortunately only, Climate Crisis for Educators. And we have many projects. So one of them, this Introduction to Green and Sustainable Chemistry, received the support from IUPAC. And of course, as a result, we have some publications. This is one of the products, like a book that was published in the Royal Society of Chemistry. And I'd like to invite you, I'm just looking the time, to know where now I am living. It's Lüneburg. It's in the north of Germany. It's a beautiful and a very, how can I say, historical place to study. And this is the university, as you can see here. And we have also as the main pillars, sustainability, but connect to other fields, economy or education, cultural studies. And I'm part of the Faculty of Sustainability. And we have some special or specific programs. And I think that it's important to mention that we have specific courses on sustainable chemistry, and also I'm in charge of green chemistry, and working with some ideas like eaten tournament or LCA, plant-based meat, or another model that I'm responsible. It's related to bioresources and many others. You can access also the link to know more about this course. And as perspective, I think that it's important to consider that green chemistry, but mostly sustainable chemistry, because we are also considering other fields, can be in the hearts when we are learning. It's not only about knowing the content, but it's to incorporate with the heart also. So it should be in the hearts and minds of our students. The importance of chemical products in various sectors, but also society. And this should be put in our chemistry courses. So our students should be able to understand the raw resources that should be required for a particular product, as well as possible alternatives, let's say better alternatives, because we can have also bad alternatives, including the non-chemistry based alternatives. So some examples could be put, but avoiding the, let's say, eco-friendly flavor, you know, when we are doing greenwashing with the curricula. So we need to avoid that. But not only in the undergrad, but the postgraduate chemistry courses should be also considered like that. And of course, we need to consider what we have published. And if you would like to know more, you can read these papers. They are related to this content that I'm discussing here. And yeah, I think it's not about universities, but all sectors, because some companies are also doing this process to educate people working with them. And I'd like to say thank you to all my co-workers and my colleagues, also from different places in Germany, in the UK, and people and the institutions, foundations supporting the work. And to Evelyn, she's my PhD student working on this topic of sustainable toys. And you are invited to know more about Lüneburg. You are invited to visit us. Now it's spring. It's a very nice time to come. Thank you very much.